Hello students, this is lesson U1A04b. By the end of the lesson, you should be able to say, I can factor trinomials with leading coefficients other than 1. In this video, I am going to go over exercise U1A04b in the attempt to factor trinomials of this form here. So I want to show you a technique. Okay, so right now this trinomial does not appear to have any GCF. And so therefore, when we factor this, okay, the technique that I had shown you in the previous video would not necessarily work, because the leading coefficient in the previous video had a leading coefficient that was 1. So what are we to do then? Okay, well, there's actually a trick, okay, that we have up our sleeves. And you can actually do this in two different ways, okay? And the first way is, I want to just show you, this is a more organized approach, and then I'll show you another way where it's just a little more intuitive and it requires a little more number sense. All of these do require a number sense of some kind, so it's just a matter of like how fluent you are. Okay, so if I have 2p squared minus 7p minus 9 here, the technique goes like this. Rather than just focusing our attention on the last number here, we're actually going to focus our attention on both of these numbers. And if I take these two numbers and find a product, I'll end up with negative 18. Right? What we want to do with this, okay, is we take these two numbers, multiply them together, then we want to find two numbers that adds to negative 7. Well, we can have a couple of combinations, actually. We can have negative 2 and positive 9. We can have not or actually, no, that's it. Oh, no, what am I saying? Negative 9 and positive 2, right? But we want the sum to add to negative 7, though. The only way that would work is this, right? The former, okay, would give us positive 7. So anyway, what we're going to do, okay, is this gets to be rewritten. 2p squared, we can actually break up the negative 7p into minus 9p plus 2p minus 9. Do you see how the middle, negative 9p plus 2p, does in fact give us negative 7p? Right? And this actually gets into a skill that we're going to look at in the upcoming video, which is factoring by grouping. So what we're going to do, okay, if you notice right now, there's a GCF up in front, and then there's a GCF. Actually, there's no GCF behind it, okay? So, however, what I'm going to do is I want to factor out the GCF in front here. So I end up with p times 2p minus 9, and then plus, and I'm going to group this. There's a GCF, and that is 1, right? 2p minus 9. If you look at this expression now, the way that it's formatted, right? Do you see a GCF overall? Do you notice that the GCF is in fact it's the binomial that's in the parentheses, right? So we have the GCF in the first half and the GCF in the second half. So what I want to do is I want to factor that out. So 2p minus 1, when factored out, I'm going to be left with p plus 1. And there you go. That is the factored form. 2p minus 1 times 2p minus 9 times p plus 1. Okay? Let's take a look at number 2. So, if I take this, okay, and again, approach it in the same manner, I want to take 5 and 8. So 5 times 8. That gets me 40. So now I want to look for two numbers to add to 40. Okay, being that this one is a little simpler than the first one because the middle coefficient there is positive, and this last number here, when multiplied together with the coefficient, is also positive, that leaves us with less combinations of numbers to work with. Okay, so this is going to be, if you think about it, what two numbers multiply together gets us 40 but add to 14? Well, that's 10 and 4. So if that's the case, I have 5x squared plus, and it doesn't matter which order you write it in, you can write 10x plus 4x, or the other way around, it doesn't matter. I'm going to write 10x plus 4x. And by inspection right now, the GCF on the first half is 5x, and I have x plus 2 plus The GCF on the second half is 2. And then I have x, I'm sorry, not 2, it's 4. And then I have x plus 2. Then if you notice, the GCF overall now of the entire expression is x plus 2, so therefore I have x plus 2 times 5x plus 4. All right. Where this method gets a little limiting is when the number at the end here gets larger, and that's when it gets really tough, okay? And sometimes just having a bit of number sense helps immensely. So what we do is, again, we take 7 times negative 54. You're going to see what I mean in just a moment. So negative 7 times, negative 54 times positive 7. What will that get us? That will get us 378. And now what you got to do is you got to think of two numbers that multiply to negative 3, that multiplies to negative 378, but at the same time adds to negative 57. You see what I mean? The numbers get a little trickier to work with, okay? Especially now we have both of these terms there that are negative. So alternatively, I want to show you another way of doing this, okay? And this does require a little bit of number sense. If you look at this, okay, this problem is quote-unquote easy, okay? And why I say it's easy is because if you look at the first term there, okay, the coefficient, it's prime, okay? That means there's only one way of writing this out. It has to be 7p. There's no other way of putting it. Okay, and then second, we got to think about numbers that multiply to negative 54, okay? So these two numbers over here has to multiply to negative 54. Just think about that. Two numbers that multiply to negative 54, okay? But then we also have to consider the number in the middle, right, that negative 57. So what we got to do in return, not only consider what two numbers multiply to negative 54, but then the end result. When we multiply 7 and half of that number plus the other half times p, that total sum should add up to negative 57. So how's that going to work? Well, negative 54, okay, what are some numbers that multiply to negative 54? That's negative 6 and 8, right? And then we can have, not 6 and 8, 6 and 9, okay? Or we can have 9 and negative 6, right? Or we can have 2 and 27, or negative 2 and positive 27, or 2 and negative 27. We can also have 3 and negative 3 and 18, negative 18, okay, or negative 3 and positive 18. But again, if you have a little bit of number sense, you should be able to tell, right? It should be this number here. I'm sorry, I miswrote this. This should say 6 and negative 9. My mistake. That's what happens when you're talking to yourself. So we have 6 and negative 9. That would work because 7 times negative 9, that's negative 63. Negative 63 plus positive 6 would give us negative 57. So this is an alternate way of doing this. Now I really don't have one preference over the other. Actually, no, I lie. I do have one preference over the other. For myself, that is. But when you do it, I don't care which way you do it. When I do it, the vast majority of the time, okay, this is the approach that I take, where I do a little bit of number sense and a little bit of guess and check. Anyhow, so that's what it would factor out to. Let's take a look at another example here. Let's go down the list here. Let's do maybe this one here. I have 10x squared minus 41x plus 21. You see how when the number out in front here, it's now no longer prime. Even the technique that I was referring to can get a little messy. However, I still do think, okay, that the guess and check and the number sense approach, it will be more efficient. However, we can approach it this way. Let's try it again. I have 21 times 10. That's 210. You see, the numbers get really big really fast, right? We want the two numbers to add to multiply to 210, but then add to negative 41. how is that going to be done? So, like, I don't even know what that is. Yeah. So for something like this, okay, I would actually take, I'm changing my mind. I'm going to do it like this instead. Okay. And again, just a little bit of number sense here. I noticed that 21 is there, right? So that means the possibilities is I have to have 3 and 7 there. And because the middle number here is negative, that means both of these must be subtraction. So now my only work is I got to figure out what has to go here. Okay, so the only way that would work, okay, where I would end up with negative 41, while at the same time these numbers multiply to 10, okay, is if I have 5 and 2, right? So I have to have 5x and 2x here. Why? Because 5 times 7, that's 35. 3 times 2, that's 6. When added together, that does give me 41. So that's the factored form. So you see what I mean? Like, if you have a little bit of number sense, okay, this approach can go a lot further. It's just that when you using this approach here, the numbers gets really big really fast and gets really confusing. So let me demonstrate that again with you guys with this one here. I have 8x squared minus 14x minus 15. So again, this one here, a little more challenging because this time now I have this negative number. That means I'm going to have the different combinations of positive and negative involved. Okay, so what I do know is, okay, that 15 there, I'm going to have 5 and 3. Okay, and then I have this 8x squared happening here. And I want the middle number to also be negative 14, which means the number that I multiply by negative should be more powerful, like it should be overpowering than the positive. Okay, so what numbers do I have to do that? I want the number in the middle to be 14. So if I do this, that means this would have to be 4x and 2x, because if I multiply these two, 2x and 3 makes 6. 5 and 4 makes 20. If I were to subtract them together, I will in fact get 14. Okay, so that means this would have to be minus, and then this would have to be plus, because I want the larger number to be negative and then the smaller number to be positive. So that's what it would be in factored form.